4.2, we're going to look at different sides of triangles and we're going to see if they are big enough to actually create a triangle. So we have a couple tests that we're going to look at. And so they're going to give us three sides, three segments, segment measurements, and we're going to decide if this is enough to actually represent a triangle. So this theorem says if it is a triangle, then the sum of the lengths of any two sides is greater than the sum of the length of the third side. Now, that seems like a lot of mumbo jumbo. All that means is if you add any two sides together, it should be greater than the third side. If that's true, then this is a triangle. So let's look at example A. If I pick any two sides, so let's do, this is representing a triangle that looks like this, where one side is 18, one side is 45, and one side is 21. That's what it's saying. We have three sides. Is this actually going to be a triangle, or is it going to look something like this, where it's not quite long enough to create a triangle? Okay, so that might be an option where it's not quite long enough to do that. So we're going to start by checking 18 plus 45. Is that greater than 21? So is 18 plus 45 greater than 21? Yes. Yes. Okay, so let's put a little check mark beside it. Now I have to pick a different two. Let's check 45 plus 21. Is that greater than 18? Yes. That's what we're checking. 45 plus 21, I would agree that is greater than 18. Then the other two sides that we need to add together, 18 plus 21, is that greater than 45? No. Well, 18 plus 21 is what? 39. 39? Is 39 greater than 45? No. It's not a triangle. It is not a triangle because this one does not work. We're going to put an X by it. And then I'm going to say specifically, not a triangle. And if it says explain, then this work right here where you're testing all three, this is your explanation. Okay? So let's look at example B. We're going to check all three sides. Is 3 plus 4 greater than 6? Yes. Okay, before I even get it out of my mouth, don't answer. Just let your classmates think about it. That one is greater than 6. 4 plus 6, is that greater than 3? I would say 10 is greater than 3. That one works. And the last pair would be 3 plus 6. Is that greater than 4? 9 greater than 4? Yes. So notice that we had to check all three sets to see if it was greater than a triangle, and I would say yes. These three measurements can make a triangle. All right, what about letter C? If I do 5 plus 7, is that greater than 12? No. 5 plus 7 is equal to 12, right? It has to be greater. It has to be greater. And so 5 plus 7 is not greater than 12. It's equal to 12, but it's not greater than 12. So as soon as you get one that does not work, you don't have to try the others. Okay, so if one of them doesn't work, you're done. This is not a triangle. All right, questions on that? What if you are only given two side lengths and you need to find another possible length? Okay, so what if, for example, I drew a triangle. Okay, I'm going to draw a triangle over here on the left. What if I drew a triangle and I said that this was 10 and this was 8, and I wanted to figure out how long does this side need to be so that it actually is a triangle? If I'm working to find this third side, there are multiple options that would work. All right, so I have this formula in yellow. Do you guys, well, on my board it's in yellow. Do you see that? It says the absolute value. Do you guys remember what absolute value means it does? What happens? Okay, it's the two hash marks on the sides. What does it mean, though? What does an absolute value of something mean?
Takes it from a negative to a positive.
Excellent. Thank you, Patrick. It keeps the number positive. So I have the absolute value of A minus B, less than C, less than A plus B. If you are a highlighter, I would be highlighting this or boxing it or something. You're going to need to know this formula. Put a star around it, something. You need to know this. Okay, it says the lengths of two sides of a triangle are 8 and 13. What are the possible lengths of the third side? So 8 and 13 are my A and my B. It doesn't matter which one is which. So if we look at our formula, it says the absolute value of A minus B less than C less than A plus B. I'm going to plug in my A and B. So I have the absolute value of 8 minus 13 less than C less than 8 plus 13. All I did was plug in the A and B into the formula. Okay, so 8 minus 13 is negative 5, right? It's still in my absolute value bars. 8 plus 13, Josh? 21. And what's the absolute value of negative 5? Just 5. Thank you, Emily. So I have 5 less than C less than 21. But what does that actually mean? If I have 8 and I have 13, that means that this other side in here can be anywhere between 5 and 21. You can pick, you don't have to pick one. You just need to tell me that the range is from 5 to 21. Because what were to happen if, for instance, what if I picked 4? Is 4 in that range? Between 5 and 21, is 4 in that range?
No.
4 is in between 5 and 21?
No.
No, it's not. So what happened if I said that this side was actually 4 though?
Then we would make it not a triangle.
You're right, because if I did 4 plus 8, is that greater than 13? Right, because that's the formula from up top. Is 12 greater than 13? So that one wouldn't work. So that's why the number has to be between 5 and 21 for it to work for the theorem up above, where any two sides added together has to be greater than the third side. So our answer here is what I have in the box in red. The range is from 5 to 21. Because it says what are the possible lengths. So you're going to have more than one answer, which is fine. You should have more than one answer on these. Okay? Questions about that? Because you'll have to do a part of that in your homework. Oh, why are you giving big huffs? So we were trying to find a range of numbers. So any numbers between 5 and 21, so 6, 7, 8, 9, 10, 11, 12, all the way up to 21. Any of those numbers would work with 8 and 13 to be part of the group that makes a triangle. And we'll do a couple more, so don't fret. All right. We're going to talk about the exterior angle inequality theorem. That's your next line there, is exterior. Exterior is your next blank there. Exterior. It says if an angle is an exterior angle of a triangle, then its measure is greater than the measure of the other of its remote interior angles. Ugh. That seems like a lot. So let's talk about this. we have a triangle here. We're going to name the angles like this. This is angle 1 down here, angle 2 up top, angle 3, and then outside out here I'm going to put this as angle 4. Okay, so label your triangle like mine. Okay, we call angle 1 and angle 2, well, first of all, let's call angle 4. Angle 4 is called an exterior angle. Anybody can guess why that's an exterior angle? There we go. It's on the exterior, it's on the outside. You guys are so smart. Then we call angle 1 and angle 2 remote interior angles. So angle 1 and angle 2, we call them remote interior angles. You with me? Okay. Brianna, can you leave the cap on for me, please? We call 1 and 2 remote interior because they are the only two that are not touching angle 4. Right? You guys see that 1 and 2 are on the inside of the triangle, but they're not touching angle 4. So we call those remote interior angles. Okay? Number 3 does not have a special name. Okay? What this rule says is that let's put an angle measurement for angle 4. Let's say angle 4 is 100. Okay? So we're going to say angle 4 is 100 degrees. The rule says that 1 and 2, when you add them together, so we'll call angle 2 30. 1 and 2, when you add them together, should equal the outside angle. So let's think about this. If my outside angle is 100, angle 2 is 30, how much does angle 1 have to be?
70.
No. 70, because together, angle 1 and angle 2 equal angle 4, right? Yes.
Oh, the measurement
Would be what?
80.
Good.
Because 4 and 3 make a linear pair.
Good. So Brianna's reminded us if we needed to find angle 3, we could. It would be 80 because they make a linear pair. Patrick?
So, I'm confused where you got the 70 from.
Okay. So I made up the angle 4 was 100. All right, are you okay with that?
Yeah.
I just said angle 4 is 100 degrees. The rule about remote interior angles is that if you add this one plus this one together, you should get the outside one. Okay? So I told you, hey, angle 2 is going to be 30 degrees. I made that up. Okay? And so if angle 2 is 30 degrees, and together 1 and 2 have to make 100, what's 100 minus 30?
70.
There you go. That's where the 70 comes from. Okay? Now, would you agree that angle 4 is greater than angle 1? Right? Because angle 4 is 100, and angle 1 is 30.
I thought that was angle 2.
I'm sorry, 2. So I will put 70 here instead. Sorry. I wasn't looking at my diagram. And then would you also agree that angle 4 is greater than angle 1? 2? I already said angle 1. Angle 4 is also greater than angle 2, right? Because 100 is greater than 30. So this rule just says, hey, the one on the outside is greater than each of the interior ones. Does that make sense? That 100 is greater than the 30, and the 100 is greater than the 70. So that's what this rule says. It says the exterior angle is greater than each remote interior angle. And we'll talk about this a little bit more. All right? what I just said? What I just said is in this thing up here, this definition. Okay, we're going to practice this a little bit more, though. Okay, let's look at, did a phone just go off? Because 3 of you just looked at your phone. Okay. Brianna, can you please put the highlighter down? It's distracting me as I'm teaching. Thank you. All right, let's look at angle side inequality theorem. I get that this is not like super exciting. It's not world changing. I get that. Okay. What this says, and this is going to be important, if one side of a triangle is longer than another side, then the angle opposite is greater than the angle opposite the shorter side. And that, right now, as I say that, it just is like Wednesday afternoon blubbery is what that sounds like. So let's draw out what this actually means. So let's draw a triangle. Okay, triangle A, B, C. Draw a triangle A, B, C. Then we're gonna put some measurements in. If I say that this is 20, 10, and 5. Okay, 20, 10, and 5. We're just creating an example. That's all we're doing. What's the longest side here? 20, right? So AB is the longest. So we're going to put AB here as the longest. What's the second longest? BC, right? So I said AB is greater than BC, right? Well, then what's the shortest side here? AC. Listen, I gave you sugar. I need you guys to talk to me, please. Okay, so you guys can agree that these sides go in order from largest to smallest, right? So what this rule says is if AB is the longest side, then the angle that is across from it is the biggest angle. That's what that means. Okay, so angle C is going to be across from AB. So angle C, even though I don't know how much the angle is not 20, I don't know how much it is. But even though it's across from it, it's the biggest. So then, what might be the second biggest angle?
B. Second biggest?
The second biggest. Which one is the middle one?
A.
Angle A. I would agree with that because angle A is across from the middle one, right? So angle A is going to be second biggest. Then angle B, right? Angle B is the smallest because it's across from the smallest side. So angle B.
Well, what is this good for, though?
When we are, so you have to understand how to do this so that you can do the problems that are a little bit more complex. Okay, so we're gonna have to be figuring out angle measurements. We're gonna have to figure out side measurements based on putting them in order from small, biggest to large. Okay, all right. So let's look at another example here. Let's draw another triangle down here for the side angle inequality, which basically says the same thing. Let's draw this like this. A, B, C. This time we're going to name our angles. So I'm going to tell you that angle A is 100. Angle B is 50. And angle C is going to be 30. That's fine. Mine's just too small. I can't put it on the inside. Okay, so now this is saying if we put our angles in order from smallest to biggest, I can put my sides in order from smallest to biggest. So let's start smallest to biggest. So I'm going to make myself a note to write small, less than medium, less than large. I know that sounds silly to write that, but please write that down. Small is less than medium, which is less than large. What's the smallest angle up here? 30 is, right? And so that's angle C. So that means angle C is the smallest angle. What's the medium angle? What's the middle angle? B. It's 50, right? Angle B. And then, Patrick, my largest angle is angle A. Guys, please make sure you're putting the little arc in your arrow symbol. Otherwise, you're going to look like you have like two less than signs right beside each other. Yeah, put your little arc through your arrow. We're not ready to flip over just yet. Okay, so if angle C is the smallest side, the smallest angle, then the side that is across from it is the smallest side. And if we look at our diagram, doesn't it look like AB is actually the smallest side? Mm-hmm. It's across from the smallest angle. Okay, so if I wanted to put my sides in order, across from angle C was how much? I'm sorry, was which one? AB is across from angle C. And if you need to, guys, draw your arrows in your diagram, like this if you need to. Across from C is segment AB. That's the smallest segment. CJ, which side is across from angle B?
Angle C.
Which side is across from angle B?
AC.
AC. So AC is going to be the middle one. And then which one is the biggest side? Josh, which side is the biggest side?
The biggest side is BC.
Good. All right, now let's do some actual examples. Let's do some practice problems on the back. Maybe. Okay, which side is the longest in the figure? Put that away. Or you can put it back here. Okay, which side is the longest in the figure? If it's asking for sides, that means I need to start with angles. So let's make ourselves a little note here. Which sides are the longest? So that means start with the angles. So we're going to start talking about the sides by looking at the angles first, right? Because I don't have any side measurements in this diagram. I have two angles and that's it. Anybody know how I might find that third angle? How might I find the third angle? Brianna?
Add them all together and set it equal to 180.
Okay, but do we know how much this angle is up here?
No, just need to add 60 plus 20 plus x.
Good. 60 plus 20 plus x.
How did you know that?
All three angles in a triangle add up to be what?
40 plus 20 plus x.
Yeah.
That's what I said.
Yes.
That's
Yeah,
what
you're
I
correct
did.
then.
I added the 40 and then 20.
So 40 plus 20 plus x equals 180. Okay. Go ahead and solve that out to find out how much our missing angle is. What are you getting, Quentin? What are you getting? What's 180 minus 60? 120. Okay, so let's put that in our diagram. We know that this angle is 120.
What are you doing? I don't. What? It maybe it's your right.
Okay, so if we put our angles in order from smallest to largest, angle C is the smallest, then angle A, then angle B. Please make sure you're writing them in this order, right? You have your less than signs, you have your angle symbols with the arc. Please make sure that, oh, did I write it wrong? CBA. Sorry, guys. Yeah, so you are paying attention. Excellent. Mm-mm.
There we go.
Angle C is less than angle B, which is less than angle A. Okay, but the question said which side is the longest? So now I need to look at the sides that are opposite. So what's across from angle C? No. Which side is across from angle C? Side AB, right? That one's across from it. So AB is going to be the smallest side. So I'm going to put AB here.
Why is that going to be the smallest?
Because it's across from the smallest angle. Would you agree that C is the smallest angle? So across from it is the smallest side. Okay? Okay, then what's our next smallest side, or our medium side? That's going to be across from 40, right? BC? Look, what's across from 40? AC, or CA, same thing. Which then leaves BC for last. So notice that your greater than sign means that BC is greater than AC and it's greater than AB. So what is the longest side here in number 1? Okay.
BC.
Angle A is the biggest, which means BC is the biggest. That's what that means. Our biggest angle up here is this one, which means our biggest side is the one that's across from it, which is BC. So you need to write BC is the longest.
So instead of doing all that, for us that we do know what we're doing, can we get past writing all that out?
Okay, so when you skip these 2 steps right here, you're going to hurt yourself as the problems get harder. So I would like you to write them. Okay? Yeah. Can you wait a few minutes? We're almost done. Okay, thank you. All right. Number 2. What are you missing in number 2? Okay, so how are you going to find out how much angle E is? Not equal to each other. Equals how much? Good, there you go. 60 plus 50 plus x equals 180. I like the way you guys are thinking. 60 plus 50 plus x equals 180. Did you do this one already?
Mm-hmm. I'm ready to.
Well, except that number 3 is going to be a little bit different, so I would like for you to stay with us, please. Okay, quickly figure out how much x is. 70. Did you guys get 70?
No.
You're getting there, Belinda. I just am a step ahead of you. So 110 plus x equals 180. You subtracted 110. X equals 70. Pick your pencil back up. You're doing exactly what I am. So we have 50 less than 60 less than 70. Okay, Emily, what's across from 50? Which side is across from 50? DE. Josh, what's across from 60? EF. Brianna, what's across from 70? What? Okay, can you put your head up for me, please? All right, so then, which one is the absolute longest, Crystal?
The absolute longest
Is which one?
is EF.
Are you sure about that, or was that a guess?
Oh no, it's DE.
Are you sure about that? Your biggest angle is 70, right? Look up here. Your biggest angle is 70. What's across from 70?
Oh, DF.
So DF is the longest.
So I was right.
DF is the longest. All right. I think on your example, we need to change something on number 3. Let me take a look real quick.
So probably change or scratch out, put 70.
Oh, okay. All right, so we just did a triangle where we had 50 and 70. What was the missing angle in a 50-70? Look up at example 2. What was that missing angle? 60, right? And in the one that we in number 2 that we just did, we had 2 angles that were 50 and 70, and the third one was 60. So we know that angle D up here is 60, so let's put that in there. Josh, what can you tell me about the triangle ABC? What do these mean?
Those sides are congruent.
Okay, if the sides are congruent, what else does that mean?
The angles are the same.
These angles are congruent?
Yeah, that one's at the bottom.
Okay, base angles are the same. So let's put this one as X and this one as X because they're the same, right? So we could figure out how much each of those are by doing X plus 20 equals 180. Okay, figure out how much each of those angles is. Okay, you got 2x equals 160.
80.
Divide by 2 and we get x to be
80.
80. Okay, so each of these angles are 80. Now, the question is, in this entire diagram, between the two triangles, which side is absolute longest? So when we have a diagram like this, we have to take it a triangle at a time. So let's look first at triangle ABC. So let's do triangle ABC in order. In triangle ABC, we only have 2 angles, right? Really, we have 20 and we have 80 and 80. So we know that 20 is less than 80. What side, Crystal, is across from 20?
BC.
BC. So BC is the smallest. And then each of those are 80, which means the AB and AC are the same length. Would you guys agree with that? AB and AC are the same length. So I'm going to write it like this. AB and AC, and I'm going to write them on top of each other because they're the same length. Okay, let's look in the other triangle here. Let's look in triangle ADC because we're going to compare. In triangle ADC, go ahead and put your angles in order from smallest to largest. So in triangle ADC, I have 50, 60, 70. Good. Okay, now put your sides that are across from them. Belinda, what side is across from 50? Okay, I don't want to hear the words I don't anymore. So look at your diagram up on the board. Okay, across from 50 is which side? Which side is this? What'd you say? Okay, angle 70 is over there, but what's this side? How would we label this side right here? Because it's across from 50. How do you name that side? CD is excellent. Yep, because CD is across, right? It's that one. Okay, so across from 50 is CD. Good. CJ, what's across from 60?
AC.
AC is across from 60. Crystal, what's across from 70? AD. All right, so now we have to compare between the two triangles. So look over here where I draw my star. Let's compare the two of them. In the blue triangle, AC and AB are the longest. But where do you notice AC is in the second triangle? It's in the middle, right? So is AC really actually the longest when we compare the two of them?
No.
It's not, right? Even though it's the longest in the blue triangle, when we look in the red triangle, it's not the longest. Which one is actually the longest, Patrick? AD is actually the longest longest side. So just because it's across from 70 and not across from 80 doesn't necessarily make it bigger. So we have to be careful with that. So AD is the longest. When you are working these, you need to make sure that you are doing them from smallest to greatest. Okay? You're working them from smallest to greatest every time that you set this up. All right?